Let me start a timer here. Okay. So good morning, everybody. Welcome to this other talk about security. This one will be a very technical talk, mainly aimed at developers. It's actually a classical talk that we do almost every year at Odoo Experience, and we try to show the best practices and the risks when you are writing code using the Odoo framework. Before starting, just a few words about ourselves. So I'm co-presenting with Denis. Denis has been, like myself, we've been for many years working at Odoo, and he's working in the security team, focusing on pen testing lately. And myself, I'm working in security and a few other things, including the platform for hosting our customers. Also, a quick note about questions. If we don't go too long, we will try to answer questions at the end of the talk, so you can prepare them on the pad there if you want. I think it's the same pad that we used yesterday, so you will find probably at the bottom the questions from the session yesterday, and we try to provide answers to the question, so it's actually interesting also about security. Before we go into some of the details about coding practices, I wanted to do a couple of reminders about stuff that can be surprising for newcomers in the development system of Odoo, in the framework. And those are a couple of points that are confusing, and we often get questions about them from even pen testers that are trying to test the security of Odoo. So a quick point about access rights. So in Odoo, the access control system is done at the database level. This is something very important. It means the ORM is the place where the security is implemented for accessing data. There is no security that is implemented in the UI, in the menus, or in even the URLs. There is no case where you have access to something just because you know the URL to this place, except, of course, when there is a secret token that is meant to secure the access. But otherwise, the access control is implemented by the access right definition that are defined in the modules and that you can customize as an administrator of the database. There are two kinds of settings that you can use to control the access. The first one is the access rights. So those are yes or no access to a whole table for one of the 4 different operations that you can do on a table. So typically creating a record, updating it, deleting it, and of course reading it. So those 4 CRUD operations, as we call them, are global to the whole table. But sometimes you want to refine the control and give access to some of the records inside a table. So some people will be able to access some of the records and not all of them. That's accomplished with what we call record rules. It's a technical model called ir.rule, and that allows you to refine the permissions within a table. So these are specified not just with Boolean checkboxes as are done with the access rights, but with expressions, conditions that we write in the syntax of Odoo domains. They look like these expressions in the domain column that you see on the slide here, and they will filter any query that you send to the database system, and only the rows that match this condition will be returned. That's how you can think of them. The thing is that they are assigned sometimes to groups, sometimes they have no group. This is an important distinction because it allows more flexibility in the way the rules are implemented. So this is a little bit tricky. You can have global rules. What we call global rules are rules that have not been assigned to a specific user group, so they apply to everybody. Typically, those global rules will be used to filter cross-company records so that people from company A cannot see a record from company B, even though all those records are in the same database table, right? And then you have group-specific rules that are assigned to the roles that you give to the users. And now it gets a little bit tricky the global rules are applied at all times. There is no way to circumvent them, whereas the local rules, the group-specific rules, are combined with the OR operation, so they are additive, and that makes sense because basically when you give a group to someone, you want to give them access to all the records that are visible for this role. So every time you give a new group to someone, they will have the new conditions that are assigned to this role, and so they will see more records. So it's a bit tricky, but it's very powerful, and it's something we were still discussing this yesterday with partners. It's something that you have to master really and to manage on a day-to-day basis, because that's the key to properly implementing security in any Odoo deployment. Another quick reminder or introduction about the RPC API. This is also something that may be surprising to newcomers in the Odoo framework. Everything that we implement in terms of business models in the different apps is exposed automatically using our API. So we have a full RPC API that is available through XML RPC or JSON RPC. It's actually explained on our documentation. And it gives access to all the models that are defined. Of course, the access rights will apply according to the user who is calling the RPC API. And there is a consequence to that, is that we also expose all the models that the methods that are defined on the model. So if you have a model for, let's say, tasks, and you create a new method on a task model, it's going to be callable through the RPC API. This is very important to remember, and this includes for portal users. Portal users are those external users that just sign up on your website, and those could be your customers or any visitors. They have actually a login to your database, and so they can call the RPC API, and they can call all those methods that you have specified on the model. So, of course, if the method is safe to call and is going to use the API, all the access rights are going to be applied. But still, there are cases where this could be a risk in terms of security, so you have to be careful with exposing those methods, and the way it works is to have private methods, and the convention is to prefix them with an underscore. So if you write a new method, you just have to always make it private by default. That's just a good best practice. And only when you think, okay, I need to call this method from a button in the UI or through an RPC call, then I will make it public, so I will remove the underscore, and that makes it accessible through the RPC API. So after this introduction, I guess we can go deeper into some of the actual examples that you have to be careful about. And we will use some material that comes from the trainings that we are giving internally to our users, the security trainings that we give. And there will be real examples coming from actual vulnerabilities that we fixed over the years. So I hope that all of your deployments are up to date in terms of security, because some of these issues are real and you need to be patched up, and we are going to show them today. I guess, Denis, you will continue with our first rule.
Yes. So our first rule today is use the cursor wisely. This is just a vague term to avoid SQL injection. It's like the most classic one of all security vulnerabilities. I do not mean us in general, but like in the whole world, like it's the introduction, it's the security 101, SQL injection. And so you would think that it's not going to happen anymore in Odoo, but we still catch them regularly before they got merged, thankfully, thanks to our runbot and our software development lifecycle. But we will show example today of what not to do with those SQL injections. So here, well, we are going to jump into details. So this is code. So in this example, there is actually two possible SQL injection and two problems in general. So the first problem here is that you can inject in the like this. Yeah, better. Okay. So you can use the parameters as IDs to inject in the SQL statement some injection. I will show it later, but basically the problem here is that the parameters are passed into the string directly using the basic string templating of Python instead of using the SQL parameters from execute. And with this, what a hacker could do is this. So they could call the RPC API on that model and then do some injection using this kind of things, this kind of, like they should just close the previous SQL statement and then look for what they are looking for. And in this case, we just show that you can call a public method on a model and have the password hopefully encrypted of the database. What should be done to avoid this? There are like 3 possible mechanisms. The first one is use the Python framework, as simple as that. So this vulnerability that we showed earlier, it used manually crafted SQL. And what we recommend to do is just to use the Python framework. In this case, no possibility to pass an SQL, to create an SQL injection, and that's it. There is also another possibility, which would be to use correctly the CR execute and pass the parameters within where they are supposed to go in the SQL parameters. There is now a third option since Odoo 17. You can use the SQL wrapper. I don't have an example here today, but we showed it yesterday in our presentation, so you can go see it. But basically, you would be able to use that SQL wrapper to combine SQL statement together and avoid this kind of situation. Then the rule number 2, and it's one of the most complicated one to review and to restrict, is the sudo. Do not over sudo it. So we will show example of how sudo can be damaging, and it's so easy to exploit and really hard to restrict. So in this example, this is like the most classic one. You can see that there is, so it's a controller where you can pass a dictionary through the post parameter, and then it's passed directly into the write as sudo. So it means that any user could use this to write anything he wants on his own partner, so any field he wants, and this is not something we want. So in this case, the controller, it was meant for the profile page, where a user can change his email, his name, etc. But in this case, if he reads the code, he can pass anything he wants in addition to just the email and name. So what should be done in this case? What should be done in this case? This is the example of what a hacker could do: is to pass any arbitrary fields to his profile and partner. And what should be done is simply to whitelist what can be passed to the post write, and that's it. And in this case, it's just the name and the email, could be the password and such things. So at first sight, it's really not easy to detect that there was an issue. For us it is, but for a new developer, it's not so easy. And so it shows that it can be very easy to exploit and very hard to see for a new developer, and you should really be careful using sudo and review it really like multiple times, and if you are not sure of yourself, get reviewed by a developer with more experience. This is another example where it's even more trickier to see what is the problem. In this case, it's not even writing something where you are not supposed to do, it's reading something. And I'm pretty sure that not a lot of people would see where is the problem in this example. And in this example, it's kind of a domain injection. So you could craft a domain starting by an OR and then override the force domain. So you would be able to overpass the force domain which is put above. So in this case, it would be to see only your last messages. You could just put an OR and override this completely. So in this case, you could
call the controller, start the domain by an OR, and then look for all messages containing password in this case. And it would be all messages, not only yours, really all messages of the database. And this is really an example on how it can be tricky how sudo can be damaging and really tricky to review. And in this case, how to fix this is there is a library. It's not a library. It's a module in Odoo, in the Odoo framework, which is called expression, and where you can connect domains together and make sure that they are valid before merging. Like each domain will be validated before being combined, and in this case, it will force to combine them with an AND instead of an OR. When there is an issue with sudo, those are the example up to where people can go, up to where hackers can go to access data. So they can read password, tokens, API keys, sensitive and private data. They can create new administrator users. We have seen cases, not real cases, but like people who participate in bug bounty programs that showed us that they were able to create new administrators. You can add the administrator group to an existing users, and you can change, for instance, the email of the administrator, then click the reset password button. You receive the email invitation to change the password of the admin, and you become yourself admin. So those are really the most critical things that can happen, because once you have this, you have complete access to the database, which is not something you want. The rule number 3, it looks dumb, but you will see that this can be really damaging as well. So it's guard password and tokens fiercely. So what it means that in some of your model, you are adding tokens, password. The best example is, for instance, payment provider. You would store the client secret of the payment provider in your database, and then you do not protect it enough. Like portal users could access those secret key and use them to make payment on your behalf. So this is a typical example. So we join back the first slides that Olivier introduced with the access rights. So it's a combination in this case. So you have the combination that the access rights give the real access to the model to all users, because there is no group added to the rule. And then you have a password field into that model. So in this case, portal users can read the Ogon passwords of your payment provider, of the Ogon provider in this case. And this is not something we made up. This is something that actually occurred in the Odoo source code. Of course, it has been fixed many years ago. This is a very old example, but it happened. And what should be done to solve this case? There are two possible solutions. Either you restrict correctly the access right in the first place, like where portal users really need, where they were really needing that access to payment acquirer in general, they shouldn't have. And another possibility is to restrict the field itself with a group that would restrict only that group, only that field to that group, if you want the rest of the model to be accessible to all users. So this is what, as I said, what a hacker could do. Simply call the RPC API, do a search ring, and read for all passwords of your Ogon providers. And what should be done? Adding the groups. This is what has been done, because it was the easiest patch in stable, was to add the group on the field. It's not even enough. Like, it's enough when you are a company of 2, 3, 4 employees, because all of your employees could possibly access that password. But for a company of 1,000 people, it's not normal that this is accessible to all your employees. So this is not even enough. You should add the group administrator, so only administrators can access that field. Now I will switch.
Let me continue.
Yeah.
You can
Yep.
go ahead. So the next rule is about C, surf, and love. Basically, the pronunciation for C surf, CSRF. So cross-site request forgery. So that's a very specific kind of vulnerability. It's a difficult one to explain, so we've tried to put some example on the slide here. but basically you can think of it as cross-site. It means that another site is able to trigger an operation on the target site, the site being attacked. Typically, you can think of it as a link or a button or something that an attacker is able to send to a victim. And when the victim presses the button or clicks on the link, it's going to immediately perform an operation on their own database system. And that's possible because the browser is keeping the session open of the victim. So whenever you make a request for their website, the browser is going to use the existing session. So even if the attacker is outside the system of the victim and doesn't have access to their session, they can send them a link that is going to use their existing session. And this can trigger, of course, a dangerous operation. So this is what a CSRF attack is about. And it can be triggered not just by links inside websites, pages. It could also be triggered by a link in an email. So there are many ways for triggering an operation that could be a cross-site operation. So this is normally prevented by the framework. Here is an example of how it could work. Let's say that there is a theoretical vulnerability with this link that is shown here on step 1. And when accessing this URL account !email equals something, let's say that this would trigger a change of email of the account of the currently logged in user. So if you were to access this URL yourself, it could change your email address in your profile. Okay, that's one example of a possible vulnerability. The hacker would then be able to send this link disguised in another page or in an email that would entice the user to click on it. And as soon as they would click, it would be game over because the operation would be triggered and the attack of the attacker would take place. This is normally prevented by the framework, and the way it works is by differentiating the calls that the browser is making to the server, depending on the HTTP method that is executed. So HTTP has different verbs or methods to describe the operations that you can do. There are get and post methods, and then you can refine there are other operations, but Odoo uses mostly get and post. So a get is typically when you want to retrieve a resource and just view it, but it's not supposed to do any change. And that's how you are supposed to use this method. So when you are implementing a module, get methods and get routes are supposed to just display data. They shouldn't make any active change in the database because they will not be expected to do that, and the browsers will have no mechanism to protect cross-site request forgery, so the attack we are describing here. The defenses that are implemented in the framework are active in the post method that is used to perform changes and to call operations on the database. The way Odoo does it automatically by default is that all HTTP routes that are exposed with the post method are protected by what we call the CSRF token. So it's a random value that we generate on the server side that we can validate to correspond to the session of the current user. And that is necessary to provide when you want to call a post method of the type HTTP. And this will be visible in most HTTP forms if you look at the source code of the web page, because you will see an input that has the type hidden. It's not visible as a field in the form, but it's passed automatically by the browser when you submit the form if you are coming from a real page that was provided to you by the server. So an attacker will not be able to know this secret, and if they make a link that tries to make a post to the server, it will be rejected because they won't have a valid CSRF token to protect it. That's one of the ways where you can protect against CSRF attacks. So here is an example of a problem that could come if you don't respect these conventions. We have an example of a route that is exposed. You see the name of the route. The type is HTTP. This is important because those are the kind of routes that can be targeted by such an attack. The problem here, probably is visible like this, is that the definition of the root doesn't restrict the method, the HTTP verb that is accessible, to post. If you don't do that, the framework by default exposes your root on both get and post methods. This means that instead of submitting a form that will be protected with a CSRF token, here you can actually just pass it in the URL. And because this root, if you look at the code, is taking a parameter, the name, and is assigning it, in this case, it's changing the name of the company. That's one example of mutation that the root could achieve. And because it was not protected by restricting it to a post, it could be triggered by just clicking on a link, as we were showing in the previous slide. This is an example of what an attacker could do. They could craft a form, or actually they could even do it with or here it's a form with the method set to get that will trigger the vulnerability. You could also actually pass it in the URL as a query parameter to trigger the same vulnerability. And of course, how would you defend against that is by restricting the method to post. In general, it should be very clear when you are writing a controller root whether it's supposed to be a method that just retrieves data and is okay to expose it as get, or whether it's a method that a root that changes the data and should be restricted to post. One thing that is important to know is that there are two types of roots in Odoo by default. There is the HTTP type, that is what we were talking about before, and there is the JSON type, another type of root that is meant to be called through a different protocol. This protocol could, in theory, be subject to the same problem of cross-site request forgery, but fortunately, it's protected by a different mechanism in Odoo, so you don't need the CSRF tokens for calling JSON routes. That's because JSON, technically, requires a different content type in the submission of the form. And this content type, because it's not one of the default content types for web forms, is restricted by browser through another mechanism called CORS, cross-origin resource sharing. So the browser will actually make a pre-flight request to verify whether this request is allowed when it comes from outside of the website in a cross-site request forgery context. In this case, it will be rejected by Odoo. So JSON routes don't need this protection. And also a small word about other mechanisms that are protecting browsers from CSRF attack. There's a new flag that exists for cookies that is supposed to protect this. So now, browsers all implement what is called the same site attribute for cookies. And by default, the same site attribute of cookies in Odoo, of session cookies, because that's what we care about here, is properly set to lax, which is the default anyway. And that means that cookies are not sent by the browser when you are in a cross-site situation normally. So that means that if you click on a link that normally performs such an attack, the browser will call, indeed, the method, but will not pass your session cookie. So you will not actually be logged in when performing the operation. So in most likelihood, it's going to fail because there is no session. So it's not a working attack. But there is a limitation with cross-site protection in this context because there is the notion of site. Same site actually is not the same as same origin. And same site actually is related to the top-level domain or the edge domain of the website. So typically for odoo.com, you have different subdomains for companies like mycompany.odoo.com, othercompany.odoo.com, and by default, these are considered to be part of the same site because they are in the same main domain. That means that those CSRF attacks are possible in a cross-site manner when you are on subdomains of the same domain. And technically, there are ways to prevent that using the public suffix list, but that's another story. The next big and very frequent issue that we have to defend against are XSS. So this is an acronym for cross-site scripting. This is another variation of attack where an external attacker is able to trigger an operation in the session of a user. But this time, it doesn't take place on the server side by executing an operation. It takes place in the browser of the victim. So this is another kind of injection attack. We talked already about SQL injection attack. This is a scripting injection attack. There are several kinds of XSS attacks. Two of them are explained here on the slide. The reflected kind of XSS attack is when you pass a parameter to a request, and it's going to be echoed back in the response of the server without being properly secured by basically escaping the parameters that are dangerous. So the example on the left shows the parameter in the URL is echoed back to show you what you search for. And of course, if you pass a dangerous HTML parameter, is going to be echoed back. And of course, if you put a script tag like this inside an HTML page, the browser is going to execute it, right? That's what is a reflected attack. So you have to click on a link that the attacker provided, and the server sends you back the answer, and the answer contains some injected logic that is going to execute in your browser. And that logic could be trigger the creation of a new user. And if you are an admin, it's going to work, and the attacker can make you create a new user, for example. Another kind of XSS attack is a stored XSS attack, where instead of crafting a link, the attacker is injecting in the database inside the value for a field. Like here we have the slide tag, and we let's say we create a tag that has the label bracket script. If the framework doesn't protect against it, if the developer didn't take care of protecting against that, when the page is rendered and shows the tags that are assigned to objects, it's going to put the label. And again, if that's not protected, we could trigger a script execution in the browser of the victim. Here is an example of an attack. There is a template. You see the QWeb syntax is used here. But otherwise, it is constructing href attribute for a link. You can see ATT href is the construction for a dynamic value for the href attribute. And it's concatenating a parameter that comes from the request, the domain. That's normally not injectable because the request only arrives on the server if the domain exists. And then a parameter that comes from the request, the query parameter, and it's called forum origin. This, of course, if it comes from the URL, is freely controllable by the attacker that is crafting a link, for instance. So what happens? So this is the part that is vulnerable here, that is underlined. If the attacker tries to use this URL, if you look at it at the top, instead of a normal forum origin with a URL or a path, we get instead a JavaScript prefix, colon, and then some JavaScript code. And if you look at what this JavaScript code is doing, for instance here, it's making an RPC call to the server. Remember, the RPC API is always open. Of course, because it's called from the browser of the victim, is going to use the session of the victim. And in this case, by the way, there is no protection from the same side cookies and so on, because we are executing the code in the window of the victim. So it comes from the original page, right? And this is going to make a write operation on the user and change their groups. And this is, for instance, you can give admin privileges to the attacker account, for instance, if the victim is an admin. So this means that the result will look like this. The victim will see the link rendered. In this case, it's the back button. And actually, the result of clicking on the link is going to execute this attack. And the victim will probably not notice it because it's just a link and they click it, right? So how you would defend against that? There are many ways to do that. Just don't craft random links. Or in this case, you could try to make the concatenation of the parameters safer by putting a slash in between them, or you could escape the value because you only expect a value that is in a given format. There are many ways to address it. You just have to be careful. Whenever you are taking input that is controllable by an attacker, you have to assume that someone will want to play with it and try to see if there is a way to perform a bad action with this. Another important topic to talk about is the open operation. It's something that you often want to do in an application, is to access some files in the module data or on the file system. There may be operations that you want to do with, I don't know, security keys that you store on the file and you have to open them and decrypt them to perform some signature, or there are many cases where an application may want to open files. Here is an example of actually a real vulnerability. This one was fixed in 2021. The CVE ID was released a long time ago. So the problem here is a method that was part of the assets management system of Odoo, where there is an open operation. You can see the last two lines on the code is with open, and it opens a file name, and then it reads it and returns it. And that's a method. You see, it's actually a private method. It's fetch content. That looks okay. It's not at least callable through RPC. That's the first good thing. But where does this self underscore file name lead us to? Well, so this shows just the open being the important call site here. Here is something that an attacker could do. You will see that this is actually writing some code. So it would require an attacker to be able to write a server action, or to at least call the create method of server actions. So they would need an admin account already. So this is a kind of vulnerability that maybe is more important in a shared model, in a SaaS-like environment, or in a multi-tenant environment, which is what Odoo is meant to support as well, where you could give admin access to someone on their own database. And you would think, okay, they can only access their own database. But because of this vulnerability, they will be able to escape the sandbox of their own database and to access other files on the host system, or even other databases of other tenants, assuming that they're not fully containerized, obviously. So here, we see the example code is calling the get asset bundle method, and you see it's crafting some parameters. Do we have a highlight for that? No, sorry. And you see the file name parameter in the middle is being passed, and it's /etc password. So this is how you control the underscore file name value that is then passed to the fetch method. You see the last call is fetch content. Obviously, if an attacker is able to make this server action, they will be able to open the etc password file and read the list of users of the system. That's just an example of what they could do. They could do many more disruptive things, like read all your secret keys that are stored in configuration files and so on. Worse than that, often you are capable of doing more than reading files. It is possibly a way of writing files as well. And writing files in such a multi-tenant environment is equivalent to a remote code execution, because as soon as you can write files on the disk, there is a good chance that you can modify a Python source file. So this means that the next time it's going to be reloaded, it's going to be executed, and you can execute arbitrary code. And by arbitrary, I mean without any restriction of the safe eval sandbox that would normally restrict you, and without needing to find exploits in other methods. You just write whatever you want on the source code, and you can mine Bitcoin, and you can do whatever you want. All right, Denis, you want to continue?
Okay, so we are still in the subject of once you gain the admin access to your database, to gain access to the machine itself, or to read things on the machine itself. So in this case, it's eval is evil. So eval is a method in Python that allows you to execute Python inside Python. And so if you give such a possibility to attackers, they will use it and perform commands, so remote code execution using it. So the recommendation is to not use it, and we will show an example of what not to do. So in this case, you can see in the code that there is an eval and in the middle of the code, and it's a simple eval. We also have what we call the safe eval. I will show it later. But in this case, an attacker, if he is able to access to control the domain within the result variable, and we will see that he is able to do it, he would be able to execute any Python he wants using this. It means, I don't know, copying files, writing files on the machine, etc. So this is an example of what could happen. We are going in deeper into the code. So it could create a server action, and so the result that we saw on the previous page is actually an action which is stored in the database. So as the hacker has already admin access, he could modify this action and write some code into the domain. So in this case, it's importing OS, so in Python, and then opening a file, again, the same etc passwd that we like to show, but as said, it could be other kind of file containing secrets like configuration, etc. And so in this case, it's reading the etc passwd file. What should be done instead of this is that in Odoo, in the Python framework of Odoo, we have what we call safe eval, which is a sandbox environment to execute code. And so in this case, instead of evaluating the domain using the simple eval, you could use our safe eval to do this and avoid this trouble. There is even a better solution, so you should go gradually. The first things to do would be to use JSON. It's not even written here, but the first things you could do is to use JSON instead. Most of the time, you could parse your domain using JSON, and that's enough. Then, if JSON is not enough, because in some cases you don't have the right quotes, because it should be double quotes instead of single quotes, then you can go to the next one, which is literal eval. And in this case, it would only evaluate a string and a list and dictionaries, etc., but it won't be able to execute code at the end. And then the last step, if JSON and literal eval is not working, then you can switch to safe eval. And the differences are explained here. Literal eval, you should use it when you don't have a variable to pass into the context. And if you need variables, in this case, for instance, you can see that the name, so in the domain name equals name, the name is a variable, and you pass the name into the context of safe eval. This is a case where you should switch to safe eval instead of literal eval. The next rule is, so still when you have admin accesses, admin privileges to the database, is get attitier, set attitier, not your friends. So those methods in Python is to access attributes of objects, and most of the time you do not need them in the Python framework of Odoo. Most of the time when you want to access dynamically a field of a model, you just use brackets to access the field you want on the model. So this is an example of what you shouldn't do. So this is a simple example where you have a method. It's a private method, but as you have admin access, you can still call it. And it would use get attitier on an object and access an attribute. Like this, it looks completely harmless, but an attacker could really go deep and accesses attributes which are supposed to be really not safe. So for instance, in this case, it's we don't have the highlights, but in this case, it would access the globals on the method. So and then using those globals, you have access to the built-ins, and then accesses the built-ins. There are really harmful things in there, such as an import. And so again, you can import OS, open a file, write a file, executing commands, etc. So it looks really harmless, those get attitier and set attitier, but they can be really, really harmful. And so you should avoid them as much as possible when you are writing code in Odoo. So in this case, self, it was a model of Odoo, and those fields you can access directly using brackets around the domain. So you didn't need the get attitr in the first place. But if you do need get attitr, then you need to make validation a lot. So you need to validate the self, that it's what you expect to be. In this case, it would be a model, so you check that it's a model. You should check what attribute you are accessing. So you could, for instance, make a whitelist of the names that you want, or let's say avoid that it starts by double underscores. And then for set attitr, you should also check what you are setting. So for instance, most of the time you want to set strings or numbers or float, but you don't want to be able to set functions, methods, other objects, etc. So the rule number 9, I didn't think that we were reached this point, but we have some time to do it, so let's do it. So it's pickle. Do not use pickle, use JSON instead. What is pickle? Is that pickle is a library into Python where you can store data, more than data, you can store objects. So it's a bit like JSON, but JSON, it can only store data, while pickle, you can store objects, so you can store methods, objects, etc. And we will show how it can be harmful. So in this case, the only place where we use pickle in our framework is within the sessions. So in this case, we are using pickle to load sessions. And so they are stored into object instead of being stored into JSON format. So if you have access to the session through another vulnerability that we shown previously, then you would be able to store code into the session file and execute it when you unpickle the file. While unpickling the file, it would execute the code that you store into the session. So yeah, this is like the hardest example of them all. But basically, so we stored into a pickle object a class which is executing code, importing OS, and executing a command on the machine. Then you store this into the session, and while unpickling the session, so when you will access your your Odoo database, it will unpickle the session and then execute the code. And bottom line is never use pickle, because there is really no reason to use pickle in the first place in Odoo. And actually, for us, it's prevented automatically because the runbot in our software development lifecycle just prevent completely to use pickle. You will have a big red warning to say don't use pickle before merging a pull request. And instead of, if you really need pickle, such as we do for the session, then we have a special pickle override in our framework, which is limiting the things you can store into a pickle. So it would be only models and strings, Boolean, numbers, etc. But in the first place, you should just not use it at all. There is no reason to use pickle in the first place. And we have a plan to change the session, so it no longer use pickle at all, and we will switch to JSON and store the session in JSON in the file system in the first place.
Maybe before we switch to the review checklist, I can just go back to, of course, the open, where I forgot to explain what was the proper way to do open. Just a quick thing that I failed to mention is that, of course, how do you fix the problem with open? Is by not using just the open built-in in Python, which is just not restricted by default, and instead use the file open method that is provided in the API, in the tools of Odoo. And what this does is to make sure that the file that you are passing is always part of the files that you are supposed to be able to read as part of an Odoo module. So it's going to look into the path of the file and make sure that it is inside the add-ons path of Odoo, so that you can never access files outside of that. What other files would you want to access? Maybe are files in the file store, but you're not supposed to use them to open them yourself, because there is an API for accessing attachments, so you don't need to open them this way. And file open also has an extra parameter where you can restrict the file extensions, so that you can also make sure, okay, even if I need to allow users to specify the path of the file in the add-ons that they want to open. I only want to allow them to open, let's say, images. So I put .png or .jpeg, and I'm sure that they will never be able to exfiltrate my Python source code, maybe. So that's how you fix problems with opens, and how we fixed our own vulnerability there. So let me just go back to the last slide. This one, Denis.
So this is our review checklist. So basically, this is the checklist that every developer should have a look to when they are reviewing a pull request. And this is what we recommend to all our experienced developers to do each time they do a review. And instead of going through the checklist, they should just remind them, okay, I saw a CR execute, what I should look for. I see a sudo, what I should look for. For sudo, in this case, it's like you cannot access arbitrary models, no arbitrary records, no arbitrary fields, and no arbitrary domain. And I won't read them all, but basically, this is it. For instance, the root that we showed earlier, is it writing something? If it does, then it needs to be a post. And I should not put cserv to false. I see an open, then it's immediate reflex, file open. Eval, you have the choice. You try to use JSON load. It doesn't work, then you can switch to literal eval. It doesn't work, then you can switch to safe eval. For get attr and set attr, same thing. As soon as you see them, then you can you have to think about using, if possible, the bracket format, and if not, you should restrict it as much as possible. And that is it. Then we have a small quote that we like very much, which is very known, is that hackers only need to get it right once, so they only need to get to know one leak, one vulnerability, while we have to think about all possibilities, and we need to get it right every time, so to make sure that hackers cannot access our system. So now if you have any question, you can freely put them on the pad. I hope there is already some.
Yes, thank you. I guess we have a few minutes to do questions,
Yep.
Or maybe from the audience, I don't know.
3 minutes? Okay.
Do you want to open the pad, or?
It's available there.
Everything. The first one is, how is it possible to ensure that there are no significant performances issues with complex record rules?
Oh, well, there's no way to ensure that other than by, I guess, looking at them and trying to determine what kind of operations they are going to do on the database. Of course, record rules have a performance impact, and that's something you have to take into account when you are writing record rules. But they're just like all the other domain search operations in Odoo. You can look at what queries are being executed when you use them. You can use the profiler that is built into Odoo to look at the queries and look at the explain plan and determine if you need indexes and so on. But definitely, record rules have an impact.
Okay, thank you. The second one is most static and dynamic security code analysis give mitigated results when scanning custom Odoo code. It can let some issues slip through. What code analysis tools does Odoo use for SEC? If it's an in-house tool, any plan to release those tools to the community?
So this is a question we had as well yesterday. We use a combination of tools. There are many parts of the static code analysis, or the code analysis for short, that are part of Odoo and integrated into the test suite of Odoo. So there is a lot of PyLint tests that are executed by the runbot and that are open sourced along with Odoo. Those are also continuously improved. We modified the SQL injection detector a lot in the past 6 months. Then we use some additional in-house tool that basically do our checklist that we saw earlier. We try to automatically detect whenever one of these patterns is coming up. We just trigger a flag and ask the user to double check it, or maybe ask for another reviewer to look at it if they are not sure what they are doing. So it's a combination of both, but we try to open source most of the tools, and we definitely will continue to share our best practices. In fact, many of the things that we have discussed today are exposed in our documentation. If you look at I think we put it in the pad, in the answers to the questions of yesterday, there are sections in the documentation. If you search for pitfalls, actually, there is a dedicated section where you can see a lot of examples, and we try to improve this section from time to time to give new best practices there as well.
And
Okay.
if I am not mistaken, for instance, the SQL injection detector is within Odoo itself, so it is open source.
Yes.
It's in Odoo.
And the last question is, are those informations available somewhere in the developer documentation?
Yeah, that's what I was basically saying.
Yeah.
Both the best practices and the pitfalls and the dangers are explained in a short version in the documentation. If you look for it, we do these talks every year, so they are also on YouTube. You can see the talks of the previous year with different variations of examples and so on. And also the vulnerabilities that we discussed and the CVEs that we've shown here. Of course, in the CVE that we publish when we disclose the issues, they have a full description on GitHub. You can look at our security page to find the link. But of course, we don't give the exploit like we did here, because that would initially be a 0-day exploit. So there is some more information in this case, but otherwise we describe all the vulnerabilities. So you have a lot of information to find there of past vulnerabilities and what I should be aware of, because it happens and we can see it because there are CVEs published for that.
Okay, thank you. I guess that people can go deep on the floor with you.
Yes,
We don't have time to answer everything.
exactly. We can finish here, and you can find us at the dev corner or just in the rooms
Thank you.
here. Thank you.
Thank you.